Okay, here's the next one. Got a rectangular solid. I drew a little picture here. And I'm labeling things. It's a square base, so I put X and X on the bottom. And it makes it a square. And I don't know what the height of this solid is, so I put that as a Y. Now I'm trying to maximize volume, so I have a volume formula for my drawing as X squared Y. And I have a surface area formula, which is 2 of these bases at X squared apiece. And then 4 sides, X times Y is each of the 4. So that's the surface area. So now that's my secondary equation. I see here, this is secondary. And this one here is the primary. Whoops. That's not going to work. Yeah, that's too red on red's no good. Okay, so that's primary. The green is primary, and the red one is secondary. And I'm trying to maximize. That's my optimization. So I'm going to find the derivative of v with respect to one of these variables. I'm going to decide to get rid of the y in this case. It seems kind of arbitrary, but it might be less work algebraically to get rid of the y. So if I solve this for y, I'm going to leave. I know s is 337.5, but I don't want to drag that around the problem with me. So I'm just going to leave it as s. I'll write this as s minus 2x over 4x is equal to y. Okay. So then over here, v, you're going to write x squared. You'll have an s minus 2x squared over 4x. Like that. Okay, now we can go ahead and multiply this. You're going to have an 1/4. You'll have an x. You'll have an s minus 2x squared. Okay, and then we can finally, we'll go ahead and write this as s x over 4 minus x cubed over 2. So expanding. So now there's my primary, and I'm ready to differentiate. So v prime, it's going to be s over 4 minus 3/2 x squared. And I'll set it to 0. And solve for x. So I have s over 4 times 2/3 equals x squared. So I did a couple steps there. That's s over 2, 3 is 6 equals x squared. So we've got the square root of 6 over, I'm sorry, not 6, but s over 6. So that's s over 6, like that. And I'm using a positive value because it wouldn't make any sense to have a negative value for x. So I leave out the plus and minus. It's just this. And that is an s, not a 5. Okay. So there's my x. And since there is only one number here that's even possible, you can assume it's your answer. But to verify, you would actually have to do first derivative test. Technically speaking, this derivative is easy enough. We could find a second derivative to verify that this is in fact a maximum. Let's do that since it's simple enough. V double prime would just be a 3x like that. And if you put a positive in here, then this would be positive s over 6. So this would be, see, it's a negative, I'm sorry. If you put a positive in here, v double prime of a positive, whatever it is, s over 6, like that, I will end up with a negative 3 root s over 6. But since it's less than 0, we know this is concave down and it's a relative maximum. So you'd be done at that point. Concave down, relative max. Okay? So it is, in fact, our answer, this answer here for x. So all we need is y, and we will have the coordinates for the maximum volume. So y, of course, is over here. This is y, so that's a little bit of work, is s minus 2x squared over 4x. So that becomes s minus 2 square root of s over 6 over 4 square root of s over 6. Okay, so that's going to be a little bit of work to get that. I think I'm going to have to give you the short version on that one. Okay, let's see. All right, we're back over here, and this is being squared. Oops, sorry about that. Too thick. Okay, so that was being squared. Let's see. Okay, I gotta cut this short. It's gonna go too long on it, but you will get a 7.5 on this number. By simplifying and putting s in, you'll get a 7.5. And also, you'll notice that x is square root of the 337.5 over the 6. It's also 7.5. Okay, so you basically have a cube. So x and y are both 7.5 units. And we can do the math to check that out. And we've already verified that we do have a relative maximum here. So good to go. X and Y are both 7.5. Okay, so that maximizes the volume. And then, by the way, that volume is, I never actually calculated that. That volume is 7.5 cubed, which is well 421.875. That's your maximum volume.